All right, we're going to start with angles today, and then 1-7 kind of finishes up angles, and that's it for this chapter. So here we go, exploring angles. You find in math that some of the terms that should seem simple are hard to define on your own. For example, one we'll get later this year. It's one of the simplest objects in math there is, but it's very hard to define. Okay, and you might want to start thinking about that one now, and it's a circle. Okay, but this one's a little bit easier. Angle. Anybody think they know what an angle is? Again, it's not that hard of a. If you saw one, you would know what it was. You'd know it was an angle, but how do you define it? Okay, maybe we said it was a degree in a plane, but there's parts that it needs to have. And as it says here, two rays with a common endpoint. That's just the definition. Is there going to be some measure to it? Yes. As was said, there's going to be some degree measure to it. And as you get further on in math, you'll realize there's other ways of measuring that angle. So, is what you see on the smartboard an angle? No. That's a what? A ray, exactly. So as it says right here, AB, notice that there's only the arrow going to the right. And when you write rays, you should always do it that way. Because really, if I show you this, is that the same thing? Are these two saying the same thing? Fortunately not. This one's saying it goes from B to A and keeps going. This one says it goes from A to B and keeps going. And which one actually happens in my picture up here is it goes from A to B and keeps going. Okay, so make sure that you're very careful with that, how you do that. And the question always comes up, well, can you put the arrow the other way? You can, but the symbol for ray is normally pointing to the right. So keep that in mind, but you already told me that was a ray. Okay. Angle BAC can be written. Well, it would help if you saw it. There it is. Well, one way you can easily write it is just go ahead and put that little angle symbol on there. You had to know that mathematicians had something. So far, the only thing we haven't really given you a good abbreviation for is plane. And that's because all those objects are used for something else later. Okay? Angle BAC is fine. Now, what if I, in this case, can I do CAB? Is that okay? Would you know what angle I was talking about if I said that? Yeah. And in this case, I can actually say angle A as well. Because you agree, is there any way, with what you see on the board, is there any way to get confused if I say angle A? No. Basically, because A is called, in this case, A is the, it's the endpoint of the rays, very true. Not what I was looking for. Yeah. Vertex. Very good. And notice, whether we do it BAC or CAB, where'd the A, that vertex, where'd it end up? Right in the middle. Okay. These are called, obviously, rays, but these are called the sides of the angle. And I think we all know right now that angle BAC is made up of two rays, and that's the point I'm trying to make. And the two rays are quite easy to see that they are AB and AC. Okay. Doesn't matter what order you told me those, and could you have said AC first and then AB? Yeah, in that case, it doesn't matter. But again, watch out with those arrows. Okay. Now, what was said earlier is there's some degree measure, and that'll normally be written in here. Perhaps this is a 70-degree angle. You know, that's fine. You know, we don't know that for sure, but that's where that kind of stuff would be written. Another thing that'll happen from time to time is they'll number the angles. They'll do it like that. And if they do that, is it okay to call that angle 1? And the question you really have to ask yourself is, if I said angle 1, would everybody else know what I was talking about? That's angle number 1, right? Yeah. Now, the times that you have to be careful are when you have more than that in there, and you can just kind of make a mental note of this right now. Right now, if I say angle A, are we all guaranteed to be looking at the same angle? No, some of you could be looking at that angle, correct? Some of you might look at that one, and some of you might be looking at that one. So is angle A enough in that case? No. Okay. But if you use three letters, for example, angle DAB, then should we all be looking at the same thing? We should. You see what I mean? That we have to talk about all this naming so that when I say it later, you're actually looking in the right spot. If I say angle DAB and you're looking off on the top right of the smartboard, well, that's a problem. Okay, because it's over here. Okay. Any questions so far? Opposite rays, basically AC and AB are what are called opposite rays in this particular case. They are also called a straight angle. Okay. That will prove to be more important than you would think. Okay. They're called opposite rays because they are going in exactly opposite directions. Okay. Well, what if I do that? Are they still opposite rays? Yeah, they're still heading in complete opposite directions. Some people think that it, well, don't move that when you do it, but some people think that it has to be sitting completely like this or completely up and down or something like that. It doesn't have to, right? They're still opposite rays as long as they're going in a complete opposite direction, and it will form a 180-degree angle. Okay. So here it says example 1. So let's name this particular angle right here. Well, I'll get you started. We'll go angle 1. Because again, we should all be looking at the right spot. That's one way you can name it, right? How about another one? Yeah. Angle FEG. Is that okay? Are you all going to be looking at the correct spot? Sure. Mm-hmm. And we'll do the opposite of that then, obviously. Angle GEF. It's the same thing, right? That's another option. And there is actually, in this case, there is one more. Yeah. Angle E is okay. Because remember, the only time you have to worry about just using the vertex is if there's more than one angle that comes off of that vertex. Then you have to be very careful. Okay? And I'd say that's pretty good. Any questions on that? Pretty straightforward, right? Angle addition postulate. This is another one of those that you see a lot of letters flying around, and it looks really, really hard when you read it. So if point R is in the interior of an angle, so at that point you would stop. What does it mean to be on the interior of an angle? Well, yes. Yeah, between the two main sides. That's a good way of saying it, or between the two rays, right? Yep. Then it's saying PQR and RQS will equal PQS. Well, this kind of sounds like that segment thing, doesn't it? Add the two together to equal the whole thing, and perhaps putting that picture in will help. Is R in the interior of the angle based on what we have? It is. And if I were to take PQR, we'll say it's right there, right? Who knows? Maybe that's not very much, is it? Maybe a 15-degree angle. And then we've got, it says RQS up there in the directions. So RQS, there's another angle, right? Yeah, that's a little bit bigger, isn't it? So we'll say 20 degrees. Would you be able to tell me how much it is from there to there? Pretty easily, right? That's just how much. It's 35. No big surprise, right? Or if I told you the whole thing was 35 degrees and turned around and say, oh, I didn't give you that one, should you be able to tell that one? Yeah, it's not really not that hard, right? Now, obviously, what's going to happen? Well, eventually, there's going to be algebra in there. We're going to have to solve for what x values is going to make it happen. But for now, it's pretty straightforward, isn't it? Okay. And as promised, some algebra. If R is in the interior of PQS, did I draw that picture for you? I did? Yeah? Okay. There you go. What's that little M? What's that? Is that a typo? What's that doing there? What is that thing? Measure. Very good. Measure of angle PQS is 70 degrees. Well, that would probably be something important to write in there, huh? So PQS, I'll just put a nice little arc there, and I'll probably put an arrow over here. The only reason I'm doing that is this problem looks like I'm going to be putting more information in there, so I might want to save some space. All right? So 70 degrees for the whole thing. Or what some people do is they'll put that out here. They'll say that's 70 degrees. Whichever way is going to work for you. Doesn't really matter to me. But then it says in here that the measure of PQR, well, that's just that top part, isn't it, is x plus 10. So this one here, x plus 10. Actually, I traced that pretty good. All right. And RQS is 2x. Determine the value of x. Oops, well, we better make a note of that. And RQS. Now, is it okay to say that RQS is just 2x? No, they want more than that. They want the value, right? They want the measure. Okay, how much is it? Well, again, it goes back to that segment thing. Do we know the two little pieces that should add up to be the whole thing? And do we know the whole thing? So then this is where you would actually add them up and set it equal to the whole thing. And so one of our little pieces is x plus 10. The other little piece is 2x. Do I know those two are the same in this problem? Is it possible that they are the same in this problem? It's possible. But do we know? No, we don't. Very, very possible that both are 35 in that angle there, but we don't know. It has to add up to be the whole thing, which we know to be 70. Now keep in mind, it is possible for them to also give you the total algebraically with an x in it. All right? But I was nice enough and I just gave you a 70 because I wanted to work on some of these algebra skills. Remember, there's an understood 1 right there, correct? So there's one x and another 2 x's on the left side here, so we can put them together, and then we have 3 x's. Can I put the 10 and make it a 13x? No. So the 10 has to stay on its own. Now, once again, is it okay if I were to divide everything by 3 right now? You can, can't you? But then you got 10 thirds, you got 70 thirds. Who wants to do that? Nobody, right? And so that's why we give you that suggestion to do that first. So let's get that out of there. 3x is still there. 10 minus 10, that's gone. The equal sign is still there. 70 minus 10, that's 60. Well, that works out fairly nice. Now, again, we're kind of towards the end here, so if we divide by 3 and get a fraction now, well, we really don't care, right? So x is, well, that comes out to be a nice number, though, so 20. Now remember, in geometry, you have to see, well, did they even want x? And I highlighted up there, determine the value of x. So yes, so we should probably circle that, and so that we can find it when we're correcting, or so that I can find it when I'm correcting. But then you have to ask yourself, can I stop and go to the next problem, or is there more for me to do? Well, in this case, there's more for me to do because we have to find the measure of RQS, which means I'm going to take this answer, I'm going to put it right in there. 4x, I'm going to replace it. That does not mean that RQS is 220 degrees. Right? You have to take 2 times 20, and so RQS actually ends up being 40 degrees, right? I'm one that likes to kind of check. Well, if that's 40, this one up here better be 30. It does actually end up being 30. Yeah, if you put 20 or right in there, because that's what x is, that ends up being 30. Why should it be 30? Because the total is supposed to be 70. There you go. Works out fairly nice, actually. Oh, one thing I will caution you on, though, is I am notorious, and so is this book, is notorious for not drawing things to scale. Okay, so it's very possible I could give you a problem like this, and you find out this one's, 70, and then this one's 20. Is that to scale? No. Does that mean you're wrong? No. Okay. If they told you the total was 90, there you go. You're good. Okay. So just watch out for that. Things don't have to be drawn to scale. And the only reason I do that, or the book will do that, is to see if you understand the concepts. Okay. Might seem mean, but it's for your benefit. All right. I think you know most of these. A right angle. I think we've actually talked about that already, haven't we, this year? Yeah. Yeah, basically an angle with measure of 90 degrees. And it sometimes is notated by that box, right, that we talked about already when we did Pythagorean theorem. Sometimes it can be just like that, or it is okay, 90 degrees. Well, remember, see, it doesn't have to be drawn to scale. They could do something like that and just tell you it's 90 degrees. Right? What you also do not want to do is if in the book it looks like that. That last one I drew, can you just assume it's a 90-degree angle? No, don't do that. Unless the directions say, if it looks like a right angle, assume it's a right angle. Then you can, okay, because I told you to. But if all they're showing you is that, please do not make that assumption. An acute angle. We should probably say greater than 0, but I think that's understood because in here you don't understand that angles can actually go negative. It's an advanced math topic. But measure less than 90, we'll just stick with that. Obtuse is one people tend to get pretty close, but not quite all the way to this one. Yeah. Ooh, there it is. That's the one that most people forget. They forget that it has to be less than 180. Well, why less than 180? What's 180? Straight angle, very good. We talked about it earlier, right? Also sometimes referred to as a line. All right. Well, earlier we had a segment bisector, right? They took a segment and put it into two sections, right? Two equal sections. Or in other words, cut it in half. Well, angle bisector is not going to take a segment and cut it in half. It's going to take an angle and cut it in half. Okay. And it's a ray that divides an angle into two congruent, there's that word again, same shape and same measure, angles. And I'll show you a little notation that we use because we do, it's very similar to the notation that we use for segments. And you may have wondered why I put so many arcs in earlier when I was doing that. Is this angle A or that angle A or this one? I put different marks in it so that they looked different. Okay. And an easy way to notate something like that is you put a little, you can just do that. Okay, those have the same arc in it. Or sometimes I like to just put another one like that. See, they have the same mark, all right? So that means they're the same. But then if this one has 2 and that one over there only has 1, are they the same anymore? No. Okay. Now if that one has 2 and that one has 2, now they're back to being the same and all that kind of stuff. All right? Again, because we're kind of lazy, so we put little marks in there. And I should probably have arrows on my rays there, but that's all right. You get the idea. Which leaves us with this one. Which is very similar to, I think, what was it, 34 for today or something like that, where you weren't given the whole thing, but you were told it was in the middle. Okay, it's very similar to that one. And I did have some questions last week on it. Determine the value of x. Okay, I might want to make a note of that. We do have to find x. And the measure of that, BE. So this ray right here is apparently bisecting CBD. So what I would do is just go ahead, put your little marks in there, whichever congruent marks you're going to use. You don't have to match mine. Match what you want. So those are apparently congruent. Okay. Now remember, when you're given two pieces, you do have the option of adding them together. That is an option. But it's only a good option if you know what the total is. Do we know angle DBC? Do we know what the total is? Say 100 or x plus 7, or no, we don't. And so that's a problem. But I do know where I have that 5x plus 10, I could also put 7x minus 2 in that same spot, couldn't I? Because they're congruent, right? And I could also put 5x plus 10 over here if I wanted to on where that 7x minus 2 is. If I can put those in the same location, that means they are the same. And in mathematics, what's another word for same? Equal. Right? So in other words, in this problem, there is some x value that if I substitute it in there and substitute it in here, they should become equal. Okay? Some of you might know that number already, but you got to just work your way towards it. Now here's a variable on both sides and a number on both sides. That's where I like to move the smaller of the two variables. Again, you don't have to. I mean, if you really felt like it, you could start this problem by dividing everything by 200. It's a horrible idea, but you could. So 10 equals. Well, of course, we're going to take 5x away from 7x, because that's where it would be most logical to line that up. That's 2x. There's 2. Right now is one of those places where you could divide everything by 2. It really wouldn't be that horrible. But if we're going to follow how you've been taught, with the suggestions you've been given, we would do that. And I believe I heard this number earlier. Divide by 2, because 2 is attached by multiplication, right? And it just so happens that 12 divided by 2 is a relatively nice number. 6. So far, I'd say that's pretty believable, so we'll circle that. We'll check, though. We'll make sure that it makes sense. They would like the measure of CBE. It's also right in the directions there, right? So you take 6 and you put it right about there. So it's 7 times 6. Here's that substitution that we worked on earlier this year. Okay, probably the first, week of school? 2 weeks of school. And, of course, our order of operations tells you that you do 42 minus 2. And so it is 40. So that angle right there is 40 degrees. So if I put 6 in here, what should I get? Because we're told it was the same, right? It was getting cut in half or bisected. And is that what happens? Well, 5 times 6 is 30, plus 10 is 40. So then this is believable. Any questions on the difference between when you know it's a bisector, when you don't? Anything like that? You're good? Okay.